Hi folks, welcome back to another video. Today I'm actually going to be doing a little bit on perspective projection, and it's just a good exercise to start to do it at the start of a class, and for anyone kind of looking to just basically learn about the setup of a question. And I'm also going to go into the different aspects in relation to the various positions of a picture plane and how that can affect the drawing. So for teachers who are setting up this question, literally I just split the page up into three. Elevation plan, as you can see, the exact same in all three locations, and then the only differences I have changed in each one is the location of the spectator and the position of A, which is where the picture planes are all going to go through, which is going to affect obviously how we complete the drawing. But just starting off, when I'm introducing this in class, and this is how we would do it, I'm just going to talk a little bit at the very start just about setting up the start of the question and the picture plane. And when I do it in one, I'm going to fast forward then and do it in this one and this one. Okay. So when we are given one of these questions, often we're just given an image, and for a lot of perspective projection you can literally complete the question by just using the plan view of the object. The only reason we really need the elevation is for the various heights, okay? So if you don't need to discover a height, often you mightn't even have to draw the elevation. But for this case I just put it in there for understanding purposes. So you can see we're dealing literally with a rectangular box. Okay, starting with the one on the left, we can see we have a spectator here in this position, and we have the box here in this position a certain distance away. Now, what we have to do is, first of all, we have to set up our picture plane. And the picture plane is where the person essentially would see the image of that box. So if you imagine a person or the spectator was standing here, and what they will see is as far left of the box here in this position and as far right of the box in this position. So essentially what we have to do is we have to join from the spectator to the extreme edge on the left and the extreme edge on the right. And that there, between those two lines, is known as their cone of vision. Now, what we have to get inside in that cone of vision, because obviously we don't know, that's their peripheral vision going off to the left and peripheral vision off to the right. What we have to get is, there's an angle inside in here, and we have to bisect that angle that was created by the cone of vision. And when we bisect that angle that was created by the cone of vision, what we're going to get is something known as the line of sight, because that line of sight is directly in the middle of the cone of vision. So, very simple there. Bisect. And when we bisect it, what we are going to do then is join up a line back to our spectator, and there we have what's known as our line of sight. Cone of vision bisected gives us our line of sight. And in this case, in the question here, essentially what we have is, I am saying for the question to be completed, we have to create a picture plane that is passing through the corner A, and we can see corner A is right on the corner of our box. So to set up the picture plane, it's just literally a little bit of sliding set squares. So often what I do is literally set up my 45 degrees long edge on the line of sight, put my 30-60 underneath it, and then rotate to the left. And passing through the corner A, I'm going to set up what's known as a picture plane. And generally a picture plane will be indicated by two letters, PP, standing for picture plane, at either side of it. Very simple. There was only a couple of steps there, and all it was from the spectator, the extreme point on the left to the extreme point on the right, setting up our cone of vision and bisecting the cone of vision to get the line of sight. And with the line of sight perpendicular to that, so I'll just put in a little symbol there, perpendicular to that line of sight, we set up the picture plane through the corner A. Okay, that is the very first steps you would always go about in completing or setting up a perspective question. Now, what I'm actually going to do is I'm going to move on to this question and this question. I'm going to speed them up, but I'll just explain exactly what I'm going to do first. So I'm going to follow the exact same steps as I did here, okay, only this time when I'm doing the picture plane, and it's passing through the corner A. In this case, we can see A is not on the corner, A is at the front. So I'm going to do the exact same steps, only my picture plane is not going to be going through the corner, it's going to be somewhere here in front. And for this one over here, we can see that my picture plane is not going to be in the corner A here, but it's going to be inside it. And that is the only difference, but it is the exact same setup. So at this point now, what I'm going to do is I'm going to just speed up the video and get that done. Okay. Okay, as we can see, even though the 3 questions were set up all the same, what is very, very much different, and you can see it's a lot different now down here, because the positioning of our spectator and where we position the picture plane has a very, very different look in all 3 questions, okay? And obviously the spectator, if he changes a slight bit to the left or a slight bit to the right, or if he, as we can see between this picture and this picture, he's actually increased, he's gone closer to the image, essentially that makes a big difference to what's going to be our final perspective view. So in this view, in comparison to this one, we're going to see this one being a lot smaller in comparison to this one where it's going to be closer. And the reason it's just closer and it's going to be bigger is because the spectator is standing closer to the object. Okay, now the next part of the question would be setting up our vanishing points and our ground line and our horizon line. Ground line, horizon line first, and then the vanishing points technically. Now, to be able to do that, I'm going to start it on this one, and then once again fast forward on these 2 over here. Okay, so I'm going to go back to this guy over here. Okay, now our vanishing points are got by essentially going parallel to the extreme edges of our object. And the way I've set up this drawing is this line is inclined is at 30 degrees and this line here is at 60 degrees, so it is. Just to make it easier for being able to complete the problems. Now, from the spectator, any lines that are going in this direction, he's going to see them going off in a 30-degree angle. Okay, so from the spectator, what I'm going to do is I'm going to go parallel to this edge, which is going in 30 degrees, as I said, this way, and from the spectator until it hits the picture plane. I'm going to do the exact same with any lines that are going in this direction, which, as I said, we're at 60 degrees. So from the spectator, once again, there we go, 60 degrees. Now, at this point, what we would usually be given in a question is, they would often say the spectator is located a certain distance away from corner A or wherever it is, and the ground line and the horizon line is 30 millimeters above the ground line. So in this case, what we're going to do is we're going to say that the horizon line is, we'll stick with 30 millimeters. I'm just guessing for now, hopefully it'll work out quite well. So the ground line is 30 millimeters, or sorry, the horizon line is 30 millimeters above the ground line. Okay, so first of all, whatever way your picture plane came out, okay, the ground line and horizon line are going to be exactly parallel to that. So what we're going to do is just a little bit of sliding set squares. So set up on your picture plane. I usually do the 45. And all I will do is, once I have that set up, I would rotate it down, or sorry, bring it down. And I just misplaced my pen there a second. There we go. And the ground line is going to be parallel to the picture plane. Okay, very simple, literally parallel to the picture plane. Alright, and now at this point, it's as I say, the horizon line is 30 millimeters above the ground line. So measure up 30, just make a little mark, and once again, sliding set squares. Now, the ground line I would always keep as heavy, horizon line I would never keep it heavy. So my horizon line, I'm using red for my construction lines. I put in nice and lightly there as much as I can. That is my horizon line. So, ground line, GL, horizon line, HL. Okay, and to locate the vanishing points, this is very, very easy at this point now. The vanishing points, if you can remember, from the spectator, we went parallel to the edge going this way. Okay, so I'll just put in that there, and this edge was this way. Now, at these points here, here, and here, what we are going to do is we are going to drop them down perpendicular to the picture plane to hit the horizon line. Okay, and that will be where our vanishing points are. So, as I said, perpendicular, this is quite easy. Literally line it up, 30, 60, or sorry, line up your 45 degree set square on it. Swivel it about. We've created a perpendicular angle here now. As you can see, 90 degrees. And what we have located in these two positions here is the positions of our VP1. And now I know it's to the L, so I'll actually just use that, and that is going to be VP2. I'll put the L out here. Okay, so the steps that we did there, very simple. Parallel to the picture plane, we set up the ground line. So they are parallel with each other, and then horizon line was 30 millimeters above our ground line. And also from the Spectator, we went parallel to the extreme edges. From the Spectator, parallel to the extreme edges, and where it hits the picture plane, here and here, drop it down and it gives us our vanishing points. Okay, those steps are always to be followed. Okay, they never really change, and the only thing that will change about them is how your picture plane is set up. So, going to do the exact same in this question here. Okay, and this question here, I'm first of all going to go parallel to the extreme edges to locate obviously the positioning of my vanishing points where I'm going to drop them down, and then I'm going to set up my ground line and horizon line as well. So I'm going to speed that up there now once again. Okay. Okay, as we can see there now, basically we have the three problems fully set up. Might look a little bit confusing on the page, but essentially if you can break it up and close off, we're going to complete them one by one now. Okay, but I hope you were able to follow that. As you can see, every setup was the exact same. The only different thing that changed was obviously how the Spectator was located and how the positioning of our picture plane was, which is going through the corner A in every one. So as you can see, our picture plane in this case passed exactly through the corner A, which is right on our actual object. The picture plane in this one is actually in front of the object. If you imagine the picture plane, it's like a piece of paper that's going up into the air like that. Okay, and in this case our picture plane is actually going through the object, and we can see that it's going to pass through at 2 points, this one and this one right here. Now obviously just managed to fit it. I was working out the page beforehand, a little bit tight for space, but I just managed to fit it. This one went slightly into the other page, but it doesn't really matter. Okay, now what I'm actually going to do is I am going to flash over to this one here, and we're going to focus on this one just for a couple of minutes to be able to complete it, and after I do this one I'll move on to this and this. So right now I'm just going to pan over to this problem here. Okay. Alright folks, so now at this stage, what I would usually do when I'm actually doing these questions is, in class I often get my students to take the masking tape off their sheets, and I get them to line up their T-square in line with the picture plane, because it just makes it easier depending on the complexity of the question. This one's quite simple now, so I'm not going to do it, but just letting you know that I usually will get them to line up their picture plane in line with their T-square, because it makes it a lot easier than having to do sliding set squares the whole time. Obviously what we're going to do here is a very basic image, so I'm not going to do that right now. Okay, now just getting on to how this question actually would start. Okay, so in this case our picture plane passes through the corner A, which is this edge right here, and if we look up at our elevation, imagine our A is down here on the ground and it has a height of 15 millimeters from here up to here. So the overall height of it is 15 millimeters. The only place that I can take true lengths from is when the picture plane is passing through a certain part or any part of this object. In this case it's touching right here at the corner A. So what I am going to do is I'm going to project down corner A parallel to my line of sight. Okay, so parallel to my line of sight, I'm going to project down corner A. And as we said, corner A touches the ground. Okay, and it's only at corner A that I can take that as a true height. Okay, any point that is on the picture plane, I can take it as a true height. So right there, I'm going to take that height, which is 15 millimeters. So I'm going to take that height on my compass, which is 15 millimeters. I'm going to mark it up. At that point there, I've now got that edge. I can heavy it in. Okay, that is the starting of my box. Okay, now the rest of this is quite straightforward. Any lines, we want to find this face here. As we see it in plan view, we see it as a line, but we can see clearly up here in elevation, it's a face of a box. Okay, going from this edge over to this edge down here. What we have to do is, we already have 2 points. We have the bottom point, which is on the ground, which is here, and we have the top point here, which is up here. And that line is going in this direction. Okay, it is going 60 degrees in that direction. And if you remember from the Spectator, any lines that are going in this direction, from the Spectator we went in this direction here. Where it hit the picture plane, we dropped it down and went to VP1. So any lines that are going in this direction are going to vanish to VP1. So what I'm going to do there is I'm going to vanish them off to VP1. Okay, now once again we have another face here. The exact same thing, just follow the opposite way. So any lines that are going from this way, in this direction, are going to vanish over in this direction here, which is in line with VP2. So any faces that are going this way, and in this case it's this face up here, that are going this way are going to vanish over to VP2. So once again, I can vanish them over to VP2. Now at this point, it's starting to take a little bit of shape. The only problem is we don't know exactly where it finishes, here or here. However, what we do know is the Spectator's view of those points on the picture plane. And look, the Spectator, as the person is looking, imagine a person here looking in this direction. He wants to see where this corner is. Well, look, his line of sight is going that way. Or sorry, this is how his line of sight technically is in here. But this is where he sees that corner. It's right here. But he doesn't see it back there. He sees it, it is back there in reality, but he sees it here on the picture plane. That's what his eyes are actually making up the object. And this is exactly where he would see it. So therefore it's going to appear foreshortened. It's going to come closer, okay? Whereas in reality we know it's further behind, but it's going to look closer to him than it actually is. Okay? So at this point here, what it's actually going to happen is, this is here, and it's going to drop down parallel to his line of sight. So, once again, sliding set squares. Drop that down. And there we go. We have found now the other edge. So I can heavy in the face. And that's that face there, which we see it as a line in plan. The exact same thing with this edge over here, this corner. Okay? Now, we know the corner is back here, it's behind the picture plane, but where the person and the Spectator sees it is here. It's where it comes through the person's sight of that corner, hits the picture plane right here. So once again, we have to drop it down parallel to the line of sight. And where that person sees it, once again, I can heavy in that there. And you can see the box starting to take shape here now. Now, the rest of it, this back corner here, I could, in reality, bring that down to my Spectator, and it would hit here, and obviously somewhere down then there. But this line here, which is the top edge, is going in this direction. We already have this point, which is here, and that line is going in that direction, which is parallel to this here, which means it's going to VP1. So literally, you could just vanish over to VP1, and then, just finish off that. And then, this point here, which we have down here in our perspective view already, which is this point, that line is going in that direction, which is parallel to this guy, which is going down to VP2. So I could vanish that point over to VP2, and there we go, we can actually see the top of our box. And it's just a case of heavying it in. What you could do afterwards is you could check your accuracy. And that's what I will do, just to see how accurate I actually was. Okay, and a way to check your accuracy was, if I was accurate, this point right here would match up with that. So, and it's the spectator's view of that actually. So from the spectator, line it up, bring it down, it's going to hit there, and that point there is where it should match up with this. We'll see how accurate I am. There's a question I just set up. Hopefully I'm not too far off. Yeah, it looks pretty close. Not too bad. Okay. Hope you found that understandable. Now what I'm going to do is I'm going to pan now to the second drawing, where in this case our picture plane wasn't right on the corner A, it was actually in front. So I'm going to pan to that there now. Okay. Okay guys, so on the second problem we have here, as we can see, there's a slight variation in the question whereby our picture plane this time is not actually touching the corner here. It's actually in front of the object, okay? So that means our object is behind the plane, okay? So that is actually going to make a little bit of a difference to how our perspective view of it is, and it's going to change a little bit. And how we actually approach that question is going to change a little bit as well, okay? Now, when these kind of things come up in an exam or things like that, it can often throw a pupil, and they're kind of going, oh, they're so used to doing it the other way when the picture plane is touching the corner. It can just throw them off a little bit, but it's not that hard. And the way to think of it is we always have to work with true heights, or true heights essentially, or true lengths, okay? And as I said previously in the last question, the height of it here is 15. Okay, so what we have to do is, and the way to start this question is, we need to find the exact position of one of these points here. Okay, now to find the exact position of one of them points there, we know the person's view of it. Just to bring, let's say if we start with this one, because it's the one that's closest to the spectator, we're going to start with him right there. So that person's view of it would be where the spectator sees it and where it hits the picture plane. So the spectator sees it in line with this, but I often, just to keep my drawings neat and tidy, I stop it here rather than bringing it into the spectator, because it can get quite messy. But where the spectator sees that point there would be right here. Okay, so in that position there, I would project it down parallel to my line of sight. Okay, parallel to my line of sight, so sliding set squares, and as I said previously, I'm not rotating my sheet, which is what I usually would do in class. Parallel to my line of sight. Now, somewhere down along that line there is going to be this point, but we have to find it. It's not on the ground line, because the ground line technically here is where the picture plane is. It's behind that, so it's going to be starting somewhere up around here. We just have to find it exactly. And the way to do that is, if we extend down, if we take this face here, see, everyone see that face there? If we take that face, which we would see as a line in plan, and if we extend that down, essentially what I'm actually getting onto here is a little bit on height lines. And if we extend that down along here, and it hits our picture plane right there. In reality, all I have actually done there is, if I actually did that up in elevation, watch, it was still at a height, as we know it's at a height of 15. So all I've done is, that line there, which is here, all I've done in elevation is I have brought that line out like that. Probably could have done a little bit more accurate there. Apologies. There we go. I could have just literally just brought it out like that. Okay? And at this point then, where it's hitting our picture plane, technically in elevation, at this point here and here is where it's hitting our picture plane. Okay, you have to try and imagine that. It's hard to visualize, but that is where it's hitting our picture plane. Okay, so what we're going to do is, at that point there, I can take it as a true height. Okay, and then vanish it back in this direction, which is going to VP2, like we did in the previous question. Okay, it's only at this point I can take it as a true height. I cannot from here measure up to 15, which is that, but out here I will be able to, and I'll bring it down. And to be able to do that, I'll show you now. So, as we have located this point, I project it down here. Up here I was just showing you the understanding. I've projected down here to my picture plane. I've extended the line down. And from there I'm going to come down parallel to my line of sight, to where it hits the ground line. Okay, it hits the ground line in this position here, and in this position here I'm now going to measure up to 15, which is of that, which is the same as this over here. I'm now going to measure up to 15. Okay, and at that point there, the line is going in this direction. At this point here, the line is going in this direction. So in that direction, it's parallel to this edge here, which is VP2. So I'm going to vanish it over to VP2. And there, now I have found a starting point. Okay? That is the height of it. That is the height of it now. Very important. That is the line up here. The ground line, if we remember, 15 technically is starting here. So, to find the base of it, will be coming from there. And technically, the space in between is my first edge. Little bit trickier. Very, very much a little bit trickier. But essentially what we have done is, if we look at this rectangle here, that rectangle there is essentially this rectangle here, which we see as a line view in plan, an edge view in plan. Okay? And now we have the first edge here, which we see as a point view in plan. We have to find where it finishes over here, because we've projected these lines over. So at this point here, you know that's the spectator's view at this of this edge at this point. Once again, project it down parallel to the line of sight. And there we go. That's that edge. Okay, now what I've done is I have got this face. Now my next job is to get this face. Okay, and we know that lines that are going in this direction are going to vanish to VP1. So at this point it becomes a little bit easier, as you've seen in the previous question how it's completed. Just going to go up to VP1, just like that. Okay, and now what we have to find is where it hits, and it hits here. Follow this into the spectator where it hits the picture plane, drop it down. There we go. That is that face. And to be able to complete the drawing, vanish it back in this direction here. And from this edge, vanish over here. And as you can see, that is a much different image. When I pan out in a while now, you'll see that that is a much different image to the first problem that we did. Okay, that is the image of the spectator's view of the object when it is behind the picture plane. But starting those questions, very, very important, we had to extend out one of the edges. I took this edge, I could have also done this edge. I technically could have done this edge, I could have brought this edge out as well. It's just working with the one that's usually closest is often the easiest way. Okay, a little bit more of understanding in that one of how to start it. You can obviously see the end result is a little bit different. Okay, so now what I'm going to do is I'm going to pan out to the final problem, whereby in this case our picture plane wasn't touching here, it wasn't outside it, but it's actually going to be on the inside of it. Okay. Okay, the final problem on this page was, or in this exercise was, whereby our picture plane was passing through the point A, which in this case on the last one is actually going through our object in our plan view. Okay, so once again there's a couple of ways that you could do it, but if you remember back to the first problem that we did whereby our picture plane was passing through the corner A, if you can remember, at that point we were able to take it as a true height. Okay, and we took it as 15 here. Now in this case our picture plane is passing through the box here, but at two distinct positions. Okay, right here and right here. Okay, now technically at those 2 points, what we can actually determine is they have true heights. Okay, and what I'll actually do is just relate up here to the elevation. So technically it's passing through there and here. Okay, and what I'm actually going to do is just put in a little bit of shading. I'll just use different pencils in there. There we go. Now, Okay, now at that exact, in that box there, as we can see in that box, that is actually where our picture plane is technically like cutting through it. It's like it's slicing that part of the box there. Okay, but at that part it cuts it in two edges, this edge here and this edge here, and at those edges we can actually take them as true heights. So they are very, very important points to start a question when our picture plane is cutting through our object. Okay, so when it is cutting through our object, what we would do is at those 2 points there and there, we are going to project them down parallel to our line of sight. Once again, like that, project them down parallel to our line of sight. So project that down and project this one down as well. And for the sake of it as well, I should have mentioned that where they are touching through, if we imagine that they are here and here, so we're going to be measuring up rather than measuring down. Okay, so where they are going up through it, what we are going to do is we are going to take them as true heights. So at this position and this position, I can now measure up the height of it, which was 15 here and here. Okay, very, very important there. Now I've technically got this line here, I have found that line, and I have found this line. Okay, and I have found them directly there. Now that line there at this one, it is going in this direction, which is parallel with this, which when we hit here in our picture plane is VP1. So at VP1, what I'm going to do is I'm going to extend it down through this, and I'll do the same with where it was hitting the ground. Okay, and this line, this point here was on this line, which is parallel with VP2. So the exact same thing. Okay, and what you should find is that these then should match up, and it looks like they do. Okay, so technically what we've actually found there is finally now the front corner, which is here. Okay, and to be able to prove that, it would be the spectator's view of it. So the spectator would look at this point, project it up where it hits the picture plane, and drop it down. And depending on my accuracy, and hopefully I'm accurate enough now, we'll see how accurate I was, it should line up with this edge here. And close enough it does. Yep. Okay. Now what we want to find is where it finishes back here. We've done this previously, so at this point here, you can see the spectator's view of this point is here on the picture plane. So at that point there, we will drop it down parallel to the spectator's line of sight. Okay, so that's that face done. And once again, spectator sees this edge, this corner right here at this point in the picture plane. So once again, drop that down parallel to the spectator's line of sight. Actually take it off one of these, a bit more accurate. Okay, and once again we have the face. And to find the top of it, line is going in this direction, so it's going to go to VP1 from this corner, and from this corner it's going to go to VP2. And if I wanted to check my accuracy, once again at the back edge, I could technically from the spectator bring this point down and it should match up with it here. Okay. Once again, you can see another bit of a difference in that question, whereby in this case the picture plane was passing through the actual object. Okay, and it was passing through here. We can see it there and there. So technically what I'll actually do now is I'm just going to shade in once again, because now that we have the 3D view of it, I'm going to actually shade in as I did up here, this here, and this is actually where it's passing through. So if I just shade in as best I can, I'll fast forward it so you can see it. Okay, So you can kind of see it there now. Essentially the picture plane, it's like it's sliced off that corner of the box there, this corner here, it's like it's sliced it off. But what we want to do is we just use the true heights of where it's sliced through. Okay, so now what I'm actually going to do is I'm just going to pan out, and what we will do is we will be able to compare the view of all three of them and how they differed. Okay, so just after panning out there, now we can actually see the difference in all three of the actual perspective drawings. Okay, starting off, just to recap, we talked through the Spectator and how to set up the original picture plane on each one of these, and it was the exact same method for every one of them, only that depending on how the Spectator was positioned and where it tells us to put the picture plane, be it corner A here, or A that was inside it, that will actually change how it's going to look. Okay, so as you can see, the picture plane was like this, to this, to this. Every one of them was a little bit different, and every Spectator was slightly different as well. Okay, and as you can see, because each of them were slightly different, each of them generates a varying results. This one obviously you can see is on the picture plane, so it's probably the middle one. This one is behind the picture plane, okay, so it's obviously the smallest one, and this one's slightly in front of the picture plane, so it's probably actually the biggest one. So you can actually see that every one of them has a different spectator view or perspective view. Alright, the last thing then was, and I explained it in all of them, as we can see the different methods and how we did, and it's all to do with the true heights. Okay, because A was touching the picture plane here, we could take that point there as a true height. It wasn't touching the picture plane in this image, so what we did was we extended down a face to bring it down here, projected it down perpendicular obviously to the picture plane, okay, and then we took the true height there and vanished it off. And then in this one it happened to be actually cutting through, and where it cut through in the position here and here, we took the two of them as true heights. Okay, so interesting video, and it's just a different view on how the perspective question can be thrown at you. I know the question itself was quite basic, but hope you found it helpful in the fact that the picture plane was positioned in different positions. For any teachers who are doing that question, quite easy to set up. Just work out some of your measurements before you have it done in a class. I made the mistake myself of having it done before I had positioned the Spectator and the A, and I just guessed them in class and they were going off the page. Okay, once again, hope you found it helpful. That's the questions complete there.